Hello students, good evening all of you. Here I discussed oxidation and reduction of the uh, glucose and fructose. Okay. So first of all here reduction of the glucose and fructose. Here in this case this compound on reduction with H2 nickel or reduction with sodium borohydride. Just here this aldehyde group is reduced to the CH2OH and remaining groups not affected. OH here, OH, this one H, and this is OH. H here, OH, hydrogen, this hydrogen. This is called as a, here initially this is the glucose. So its reduced product is known as a glucitol or also known as a sorbitol. Glucitol or sorbitol. Okay. So glucose and reduction with H2 nickel sodium borohydride, glucitol or sorbitol. Now here, this one reduction with this one, HI. HI also reducing agent. In the presence of the red phosphorus, we'll get the N-hexane. It is a complete reduction of that glucose. Okay, a complete reduction. For suppose, of course, this one also on reduction with HI in the presence of the red phosphorus, the product is same. Okay, N-hexane is the product. Of course, here formation of the N-hexane denotes there is a presence of the 6 carbons in glucose in a straight chain. Okay, that's it. Now here coming to the fructose. This fructose on reduction with H2 nickel or sodium borohydride NaBH4. The product is also here. In this case CH2OH same, CH2OH same. Next here one newly generated chiral carbon OH. This one OH. This is the OH. Now it becomes a sp3 carbon. It is initially sp2 carbon, is not chiral carbon. After reduction that becomes OH and H. Because hydrogen added to the oxygen here, one hydrogen added to the carbon, it becomes a sp3. So in this case OH may be right side or OH may be left side. That means here we'll get the two isomers. CH2OH, this one OH, this is OH and this is H. Here OH hydrogen, this hydrogen, here CH2OH. So these two products are formed. These two are not mirror images. So of course here these two are the diastereomers because differ configuration at the only one chiral carbon. That is a newly generated chiral carbon. So here fructose has initially 3 chiral carbons, but after reduction in the product we have a 4 chiral carbons. Okay. Of course, in this reduction we have a we will get the two products. Okay. Now here this product is nothing but sorbitol or glucitol. Okay, sorbitol or glucitol. Now here this product is known as a mannitol. This product is called as a mannitol. For suppose the mannose on reduction, okay, mannose and glucose are the C2Fers. Okay, so here mannose on reduction, you will get the mannitol. That means here for suppose this one CHO, here CH2OH, here OH on the right side, here OH right side, H left side, H left side. This is the OH, H. This is the mannose actually. Okay, mannose on reduction with H2 nickel or sodium borohydride. Here we'll get this one. Sodium borohydride will get the mannitol. But your fructose on reduction will get the both sorbitol and mannitol in equal amounts. The glucose on reduction will get the sorbitol, mannose on reduction will get the mannitol. But here the fructose on reduction will get the both sorbitol and mannitol in 50-50%, and these two are the diastereomers. Okay, that's it. Now here this one also reduction with the HI with red phosphorus will get the N-hexane. It's a complete reduction of the compound. That means here all OH groups converted to H and this keto group is converted to CH2. That's it. Here C double bond OH, aldehyde group is also converted to, that CO group is converted to CH2. The remaining hydrogen, that means it is a CH3. Okay, there is a reduction of the glucose and fructose. Okay, that's it. So next we'll discuss the oxidation of glucose and fructose. In oxidation of glucose and fructose, the first of all, we'll discuss this this reaction. Okay. Yeah, this glucose on reduction with bromine water. Yeah, bromine water is a weak oxidizing agent, so more react to aldehyde group is oxidized only. That is converted to COH. So remaining all groups same configuration. CH2OH. Remaining all alcohol groups are not affected. OH here a hydrogen. This is OH hydrogen. This hydrogen. This compound is named as a gluconic acid. This compound is known as a gluconic acid or aldonic acid. Okay, it is a monocarboxylic acid. This is a monocarboxylic acid. Okay, of course here this one also reduction with HI, red phosphorus, will get the N-hexane. Okay, this COH also reduced to the CH3. Okay, with red phosphorus and HI. Now here the same glucose, okay, the same glucose on reaction with the HNO3. Okay, on reaction with the HNO3, this aldehyde group is oxidized to the acid, and primary alcohol group is also oxidized to the acid with the HNO3. That means here COOH remaining CHOH groups same configuration 4 times. Here COOH, that means here this primary alcohol group is oxidized by the HNO3. Okay, of course here reaction with the HNO3 glucose produce this dicarboxylic acid. It denotes presence of the this CH2OH group, primary alcoholic group also. Okay, of course here these are the secondary alcoholic groups. One is the primary alcoholic groups are present in a glucose. Okay, so in this case this is known as a glucaric acid. This is known as a glucaric acid or aldaric acid. Aldaric acid are also known as a saccharic acid. Okay, also known as a saccharic acid. Of course, this one also reduced by the red phosphorus and HI will get the N-hexane, the product. Okay, that's it. Now here, this fructose on reaction with the bromine water, we cannot see the positive reaction. That means here these ketones are not oxidized by the bromine water, but aldehyde is oxidized by the bromine water. Okay, that is the oxidation of the glucose and fructose. Okay, and for the structure of the maltose and for the structure of the lactose, and one more question. There is a previous question from the carbohydrates. Okay, so we can see my videos. Okay, those are in a playlist actually. Okay, thank you. Please subscribe to my channel.